Hello, my dear student. How are you? I hope you are all will be fine. I'm also fine. Thank you. Welcome to our channel. Let's start today topic. Today is lecture number 2 of nucleophilic substitution reaction. Today is we will study in today lecture generality of Sn2 reaction. Mostly reaction of Sn2. Mostly reactions take place by the Sn2 mechanism. The reaction of an alkyl halide such as methyl iodide with hydroxide ion gives an alcohol. Other nucleophiles convert some other nucleophile instead of OH. Here is, let's suppose generally this is nucleophile. Some other nucleophile converts alkyl halide into variety of functional groups, different functional groups. The following tables, I show you the following, the different uh, nucleophile having different products. Let's I show you. First of all, when there is alkyl halide, when there is RX instead of OH group or in nucleophile, when there is iodide ion used as a nucleophile, so it will produce alkyl halide. It will produce alkyl halide. But actually, alkyl halide, it is very difficult. The formation of alkyl halide, the formation of alkyl iodide is very difficult formation. But in aprotic solvent, it can be formed. In aprotic solvent, it can be formed. This reaction is also called halogen exchange reaction. Exchange reaction. Halogen exchange reaction, the Sn2 reaction provide a useful method for synthesizing alkyl iodide and fluoride, which are more difficult to make than alkyl chloride and alkyl bromides. Halides can be converted to other halide by halogen called halogen exchange reaction, in which one halide displaces to another. Iodide is a good nucleophile. It is a very good nucleophile. Many alkyl chloride like RCl, alkyl chloride, or you can say CH3Cl. Many alkyl chloride react with sodium iodide. It can react with sodium iodide NaI, which is very good nucleophile. Iodine is a very good nucleophile. To give in alkyl iodide, it also give in alkyl iodide CH3I. But it is very difficult process. The activation energy for this reaction is very high. First of all, activation energy is very high because both groups are attached. The leaving group as well as nucleophile both belongs from same group, that is halogen group. But only the difference is iodide ion has a large size while chlorine ion has small size. Only the difference. That's why activation energy will be very high, as well as first we should need to that this base instead of sodium, this will be very high. This will be very high base that act as a very high base. That will be strong base. NaI is not enough strong like Ki. Ki is very strong base. So our Kf, yeah, Ki is very strong base instead of NaI. Yeah, so Ki will be the product of CH3I. In case of when we use Ki as a reactant, the product will be formed. The product will be formed fastly as compared to when we use the reactant as a reactant NaI, sodium iodide. Is it clear? Yeah, that is clear. But instead of iodine ion, when we use, that is when case of RX alkyl halide, when it react with Kf, that is when we replace the fluoride ion. This is very difficult synthesis. The formation, the RIF will be very difficult. Synthesis of RF will be very difficult. Why it will be very difficult? It will be very difficult because here in this case fluorine has a negative charge. It has negative charge, high electronegativity. Also Also it has low ionization, low polarizability. It has low polarizability, so the reaction will be very fast, very slow. But in case of when we use the solvent, like a crown ether, like a crown ether when we use the solvent like a crown ether, in this case, in this situation, when the solvent is the crown ether is, the formula of crown ether is 18. It is also called 18 crown 6. It is also called crown ether is also 18 crown 6, and this and his structure is, it is aprotic solvent. It is aprotic solvent. What is mean by protic solvent and aprotic solvent? Both are protic solvent as well as aprotic solvent. Both are polar in nature. Both are polar. While non-polar is, other thing. Here aprotic solvent and protic solvent both are polar thing, but only the difference is protic solvent can make hydrogen bond. Protic solvent will always contain, it should be contain NH bond as well as OH bond. It should be contain OH and NH bond, while aprotic solvent cannot be have these bonded OH and NH. Other than all those compound that have other than OH, all those polar compound that have not, that hadn't OH groups. OH groups are NH groups, so that's why they cannot be formed hydrogen bonding with any nucleophile. So that's why in case of aprotic solvent, the nucleophile will be act as a good nucleophile. It will be act as a strong nucleophile, very strong nucleophile. Let's I show you the 18 crown 6 compound or crown ether. The structure of 18 crown 6 is or crown ether is, it is like this. The structure of 18 crown ether is this. This is the 18th crown structure. When there is HF used, when there is HF used, in case of when the reaction is like that, when the reaction is like that, that is RCl plus HF plus KF, not HF, plus KF plus KF, the product will be RF plus Cl negative. So why the fluoride ion substitute the chlorine, while the fluoride even the fluoride ion has smaller size than chloride ion, means fluoride ion has low polarizability while chlorine has high polarizability. Then why? It is because that in case of when here is used ether crown, when here is used the solvent crown ether, that is crown ether, or we can also you can also use the term 18 crown. It is called, this formula is called 18 crown 6. That is aprotic solvent, that is aprotic solvent, that is aprotic compound. So in this case, in this solvent, the K will be dissociate here like that. The K will be this, that is K plus. So the K will be dissociate this. Only fluoride ion will be remaining in the solution. So this will be in this case, only the fluoride ion concentration will be very high. When this concentration is very high, then that can, in this case, in this solvent, that can be replaced the alkyl, the halogen group of alkyl, and synthesize the RF group, the fluoride halogen, the methyl or alkyl fluoride. It will be produced, it will be synthesized alkyl fluoride. Sorry. These are the reaction of when we use the fluoride ion, when we use to synthesize, when we want to synthesize the fluoride, alkyl fluoride, then it will be, then we should need in this case we should need that we should be used the aprotic solvent. In case of aprotic solvent, 18 crown 6 ether will be used, must be used. We will discuss later in separate video and the difference between aprotic solvent and protic solvent later, but now we concentrate on nucleophilic substitution reaction. The general reaction of alkyl halide, the general reaction of nucleophilic substitution reaction is when nucleophile attack on alkyl halide, it produce nucleophile, uh, alkyl nucleophile plus halide ion. So when we use the instead of nucleophile, when we use here is Rx plus when we use iodide ion, it will produce alkyl iodide plus alkyl halide, or it can be also called alkyl halide. It is alkyl halide. When we use here iodide is a nucleophile. When we use OH is a nucleophile, it produce alcohol. It produce alcohol. ROH, it is alcohol. When we use the OR group instead of nucleophile, when we use OR group as a nucleophile, it will act as a OR negative. It will be produce ether. It will be produce ether. When we use SH group instead of SH group is a nucleophile, it produce thiol. It produce thiol. When we use SR group SR group, it produce when we use SR group as a nucleophile, it produce thioether. It produce thioether, RSR. It is thioether. When we use NH3 group, NH3 as a nucleophile, it produce amine, RNH3, NH3 plus and X negative. It is amine. When we use N3 group, as a nucleophile, when we use N3 as a nucleophile, it produce azide. It produce azide, RN double N bond N double bond N. It produce azide. So here is different groups, and when we use as a nucleophile, it produce different compound, different functional groups. Even carboxylic acid can also be formed. Even ester can be formed. Ester can be formed by using RC double bond O group. RC double bond group, it produce RC double bond OR, which is ester. And also nitrile can be also formed. Phosphonium salt can also be formed. So these are the generality of Sn2 reaction. When we use different nucleophile, it produce different functional group atoms. It produce different functional groups like that may be alkyl halide, alcohol, ether, thiol, thioester, amine, amide, azide, ester, nitrile. So these are different things. Nitrile. So these are different things that can be. These are different products that can be formed by reacting different nucleophile with alkyl halide. It produces a different compound. I hope today's lecture will be clear. If you have any confusion, if you have any question, you can ask me in comment section. Okay, thank you. Very best of luck, my dear student. Very best of luck.